Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with prescriptive analytics and that too coverage on integer programming. In fact, in the last couple of lectures we have discussed the concept of linear programming, where the requirement is to optimize the business problem and to find out the values of the decision variable through which we can address the business problem more effectively and as per the management requirement. And typically in the last two lectures we have discussed the concept of integer programming, where the requirement is something more than the kind of general linear programming problem. So, it is the case where we are not optimizing the kind of models where we can take a kind of decision, but the decision in such a way that the values of the decision variable should be integer type, because in reality some of the business problems. So, the focus or the kind of decision will be more effective and the more efficient if the values of the decisions variable will be coming the kind of integer type. So, as a result we have discussed these problems, what is the need or the kind of scope of integer programming, and in fact, we have also solved some of the problems typically by using cutting plane mechanism CPM and then branch and bound mechanism. And in fact, we have also used a solver package to solve problems and look for the integer type solutions. In fact, manually it is like simple linear programming problem. We start with the kind of optimal solutions. So, once we reach the optimal solution by graphical technique or simplex technique, then we like to see whether the particular problem is optimal and satisfy all constraints, all conditions, and also the values of the decision variables are integer type. If that is not the case, then integer programming has a role, and that too we can use either cutting plane mechanism or branch and bound mechanism to again revisit the particular optimal solutions and then look for the further optimal solutions or alternative optimal solutions, where the values of the decision variable will be integer type and the problem is also optimal one. And what we have discussed in the last couple of lectures. So, with respect to original problems and the kind of original optimality and which is not integer type, then this is a kind of additional constraints or additional conditions. As a result, so we can look for an alternative solutions where the values of the decision variable will be integer type, and we have seen. So, when we put the restriction of integer type, then the value of the objective function will be little bit compromised. So, as a result, so original optimal solution, the values of the objective function and the solution where the values of the decision variable are integer type, where the objective function value will be little bit lower compared to the original optimal solution. So, that means, since it is a kind of additional constraint, then we have a kind of solutions which can satisfy the business requirement, but the values of the objective function will be compromised. So, that is how the typical structure, and in the last lecture we have discussed about the cutting plane mechanisms. Now, here we are discussing the concept by branch and bound mechanisms and the kind of 0-1 integer programming. And so, for that, so this typical structure is like this. So, what I have already mentioned, it is the structure of sensitivity analysis, and there are two parts. If you go by manually, then simple problems go by primal kind of solution by using simplex mechanism, and then you have to check whether the type of solution is optimal and then integer type. If not, then again we have to add a constraints, either cutting plane mechanism or branch and bound mechanism, then again start the iterative process till you get optimal solution which is integer type again. So, for that the second part or the second phase of this particular process is nothing but sensitivity analysis structure, and mostly we use actually dual simplex mechanism again to solve the second part of the problem, to solve the solution to solve the problem again to get the solution which is actually integer type. So, that means it is a kind of mixture of primal simplex, dual simplex and the application of sensitivity analysis, and it is as per the business requirement and the kind of management requirement. So, corresponding to the kind of discussion which we have in the earlier. So, the branch and bound mechanism. So, that means we like to check whether the values of the decision variable are integer type or not. If not, then the particular variable which you can find out out of all the variables. So, can have two different branch, then again there are two different constants, and accordingly there are two different models to check and then look for the optimal solution. So, like means that is how this particular mechanism is called as branch and bound mechanism. So, it is like decision tree. So, it has a lots of branching till you get an optimal solution which is actually integer type, and the second mechanism is we have to solve the problems where the values of the decision variable will be binary in nature, that is 0 1 interval only. So, that means 0 so that means either 0 or 1s, not in between. So, that means technically, so we can use the branch and bound mechanism, and then we use a kind of mechanism where the values of the decision variable will be integer, and that too strictly within the kind of structure of 0 and 1 only, that is the binary numbers only. So, let us see how is the kind of structure, and so far as formulating integer programming is concerned. So, we have either or alternatives and k out of n alternatives, if then alternatives, either or constants, and variables that have minimum level requirement. So, these are all actually kind of structure. So, the some of the specialized integer programming problems are fixed charge problem, where we like to minimize total cost, set covering problems where we minimize coverage cost. So, likewise we have a couple of specialized integer programming. So, that means this will give you the kind of snapshot that integer programming problem is having a special kind of entity in the prescriptive analytics, where some of the business problem highly requires, and without such kind of tool, it is very difficult sometimes to predict the business requirement or to predict the management requirement, and then you may not be in a position to come with a kind of management decision through which you can address the problem more effectively. So, as a result, so we like to check the kind of structure integer programming. So, what we have already discussed here. So, this is a simple example of integer programming, where we have maximization maximizing a objective function z equal to 6 x 1 8 x 2, and we have two constants less than type both are less than type, and x 1 x 2 greater than 0. So, that is the non-negativity restriction, and then the solution must be integer type. So, that means the in the optimal stage. So, the values of the decision variable must be integer type. So, with this we can start the particular process and then check how is the kind of So, we can have also graphical structure, since it is actually with respect to two variables, and if it is the case of more than two variables, then we can go by a algebraic method or simplex method to solve the problems and look for the optimality and then the integer type solution. And in fact, after solving this particular problem, so the solution is like this, and the initial solution is here like this the z value is 51.50, which is not actually our requirement. Our requirement is to check whether the values of the decision variable is integer type or not. If that is the case, then we can look the value of the objective functions. If the values of the decision variables are not integer type, then no point to check the value of the objective function, because this is our requirement and this is our the condition. So, since both the variables are not integer type for this corresponding problem, so as a result, so we like to, so corresponding to this particular problem, so the this problem, so the solution will be x 1 equal to 5.25 and x 2 equal to 2.5. So, as a result, both are having actually a non integer. So, then we start the branching. So, the branching can be with respect to either x 1 or x 2, but there is a system through which you can choose a particular variable, and as a result let us start with choosing x 2 because it the kind of the non-integer value is 0.50 which is higher than compared to x 1 which is 0.25. So, as a result, so x 2 is 2.5, and so what is happening here? So, we like to put the kind of structure here. So, this will be giving you two different branching, and that too one is with respect to x 2 less than equal to 2 corresponding x 2 here 2.50, and another constant will be x 2 greater than equal to 3. So, that is how the two different branching can be done. So, that means the original problem maximizing z equal to c x, and we have two different constants, then this will be third constant to this problem. Again the same original problem will be here, and this is the third constant will be added. So, now technically we have two different sub problems. So, sub problem 1 and then sub problem 2. Again we solve these problems and get the optimal solutions and check whether they are integer type. Again we will solve here and look for the optimal solutions and check whether the solution is integer type or not. If both the cases it is integer type and we reach the optimality, then that could be a final solution, and we can have two best alternatives and then find out which one is the best as per the particular problem requirement or business requirement. So, that means technically corresponding to this problem. So, we have two different sub problems. So, now we look for the solution of these two sub problems. So, where x 2 less than equal to 2 and x 2 greater than equal to 3. So, that means corresponding to original graphical plotting. So, now we have to add actually two different constant here, then we look for the solution. So, now the corresponding this is the original problem, this is what the original problem. Now, so the first partition will be x 2 less than equal to 2 and second partition is x 2 greater than equal to 3. So, now this is additional constants and corresponding to this. So, we have a solution here, and that too x 2 is integer type and x 1 is not integer type. Again corresponding to x 2 greater than 3. So, we have x 1 4.5 and x 2 equal to 3. So, that means in this case x 1 is not integer and x 2 is integer. Again here x 2 is integer and x 1 is not integer. So, that means, so now using x 1, so then we will have here two different branching. One is x 1 less than equal to 5 and another one x 1 greater than to 5, similarly greater than to 6, and similarly here one constant will be x 1 less than equal to 4 and the other one will be x 1 greater than equal to 5. So, then that means technically corresponding to original problem and the optimal solution, we have two different branch problems, and then again corresponding to different branch we have two different sub problems again. So, that means technically now we have four different sub problems, and again we like to check the optimal solutions, and then we like to compare and finally conclude which one is the best requirement for this business problem. So, so as a result, so we like to move the kind of procedure. So, obviously, so the next procedure is so we like to add these two constants and then look for the optimal solution, and this is what the particular structure here. So, corresponding to the original problem here, and this is what the solution. So, now keeping this one constant, so we can look for this one, and here this is 4.5. So, one will be x 1 less than equal to 4 and another one is x 1 greater than equal to 5. So, now again this is fourth constant to the original problem. So, as a result we look for again optimal solution. So, after the optimal solution we have x 1 again integer type and x 2 is non integer type. Again, so in this case putting x 1 greater than equal to 5. So, our indication is that infeasible one. So, that means so the loop will be closed here in this side and the loop will continue here. So, that means it can have a two different branching again. So, one will be x 2 less than equal to 3, another will be x 2 greater than equal to 4. So, that means again two different sub problems. Then we look for the again optimal solutions as per the particular requirement. So, now again, so we add that particular constant, then look for the solution, and then this is what the final structure. So, this is what the original problem, and the this is first branching, this is second branching compared to this one. So, we like to start with this side. So, we have a two different sub branching, since it is infeasible. So, this could be again solved, and then the final solution will be like this. So, corresponding to non integer. So, we have again two different sub problems, and then we look for the particular solution, and here. So, putting this particular additional constant, the final solution will be here like this. So, x 1 equal to 4, x 2 equal to 3, that where z equal to 48, and again x 1 equal to 3 and x 2 equal to 4. So, this is where z equal to 50. So, that means original, in the original optimal solution we have a z equal to 51.50 and x 1 where x 1 equal to 5.25 and x 2 equal to 2.50. So, that means you compare this one, and now the final optimal solutions we have here and we have here. So, now so these three will be the mirror image where we can compare, and then finally fix which one is the best requirement. So, now if you look into the objective function value. So, this is the highest and this is second highest, this is third highest. So, as a result we like to pick up a particular solution where the value of objective function will be highest, and in the same time values of the decision variable will be integer types. So, keeping these two requirements, so this can be rejected, and again, so this is integer type, the values of the decision variable here integer type, here the values of the decision variable are integer type. So, that means both can be accepted, and in that context, so we like to check which one is having high z values. So, that is objective function value. So, in that context, so this is highest z value, and where the values of the decision variable are also integer type. So, that means technically, so this is not the optimal case, because here the values of the decision variable are not integer type. So, these two can be, but with respect to high z value. So, finally, the option is so means final the optimal solution will be where the z equal to 50 and x 1 equal to 3 and x 2 equal to 3. So, this is how the kind of typical model, and so these are the kind of structure through which you can take the kind of decisions as per the particular business requirement. That means if you look into this figures, so you will find it is a very interesting, and in fact it is a kind of continuous process. The entire linear programming problem is the is the structure of iterative process. Again, within the iterative process, this branch and bound is again further kind of interesting iterative steps, and you will continue till you get a kind of final remarks corresponding to the particular business problem, where we have to reach the optimal solutions, and the values of the decision variable should be integer type. So, these are the kind of structure through which you can analyze the particular problem. And now, so if you sum up, then you will find you will find there are two different steps altogether. In the first steps corresponding to original problem, use either graphical mechanisms or a simplex mechanism to get the solution, that is the optimal solution, and check whether the values of the decision variable are integer type or not. So, if they are coming integer type, then you can stop and not need to go further and analyze the problem as per the particular business requirement. But if the values of the decision variable are not integer type, then you have to proceed further kind of iterative process to get the alternative solution, where the value of the optimal solution or values of the decision variable will be integer type. So, we have discussed two different mechanisms, and both are very interesting, and it will give you some kind of confidence and different alternatives through which every stage you will find the improvement with respect to value of the objective functions and corresponding to the constants and conditions. So, that means corresponding to a particular business problem or management problem, we have a several kind of alternatives, several kind of structure. So, it is you to decide how you have to fix up a particular solutions corresponding to management requirement. And once you select a particular solution corresponding to the management problem, so you can take the decision effectively. So, this is how the kind of structure. So, the other aspect of integer type solution is you may have a pure integer type, mixed integer type, and then kind of 0 1 integer type, right. So, which we have already discussed, and in the case of mixed integer, some are integer type and some are not necessarily integer type. So, it depends upon the problem to problem and the kind of game to game. So, depending upon our requirement, we have to operate the process. Then we will look for the optimal solution and the values of the decision variable through which you can address the business problem. And this is another kind of structure where the particular problem is having kind of operation. So, let us say, so this is second iterative process. So, that means in the last solutions which you target is with respect to x 2. So, now we are targeting here x 1s. So, that means in the last particular last solutions we have targeted the x 2 branching. So, now you can go through x 1 branching. So, since x 1 is 5.25. So, there are two different constants again. So, one will be x 1 less than equal to 5 and another one is x 1 greater than to 6. Again we start the process, and here you will find this is actually a solutions corresponding to this additional constants, and where x 1 is integer type and x 2 is non integer type, and that is what it is called as mixed integer programming. And again in this case we have value of the optimum functions, and x 1 equal to 6 and x 2 equal to 1.43, and that means technically x 1 is integer type and x 2 is not integer type. It is again optimal mixed integer solutions. So, that means technically if you go through the previous structures corresponding to the previous structure, you will find so these are all kind of mixed integer kind of things. So, this is a mixed integer, and this is pure integer, this is pure integer, this is mixed integer, and this is actually completely non integer. So, we have a different kind of problem requirement, you have to fix if for instance if this is a case where x 2 is integer and x 1 is a non integer. So, you look into the problems, if x 1 corresponding to x 1s, if there is no such requirement of integer, then we can actually fix there, because that value may be higher compared to this value. Of course, we have another solution here where the value of the objective function will be higher compared to the previous one. So, as a result this could be the best solutions. So, now coming through the the particular structure. So, we will find the other part of the problem which is having two different branching again, and then again we look for the solutions, and again so here we have actually a x 1 equal to 5.25 and x 2 equal to 2.50, then x 1 can be actually having different divisions. One is less than equal to 2, another is greater than equal to 3. Then again we have a solution, and this is what actually called as mixed integer solutions. So, now whatever we have discussed till now, it is the kind of integer type solution and mixed integer type solutions, and then kind of completely non integer type of solution. That means, we have a three different situation: pure integer, mixed integers, and completely non integers. So, now we have a fourth different kind of structure where the values of the variables decision variables are integer type, and that to restrict on 0 1 only. So, either 0 or 1. So, that means, it is again strict restriction or strict kind of requirement, and there are certain business problems such kind of requirement is also highly required, and then we again go for the branch and bound mechanism to solve the problems, and then look for the optimal solution where the values of the decision variable will be either 0 or 1. So, like we have discussed the concept like binary choice model, or linear probability model in the case of kind of predictive analytics. So, now this is a mechanism through which actually you will find different kind of constraints and the kind of conditions through which we look for the various alternatives and the kind of optimal solution, and then look for the a kind of solution where the values of the decision variable will be 0 1 type only, and that to integer. Again it is a strict kind of requirement, either 0 or 1. So, let us say this is a problem here, and here the problem is with respect to 4 variables, and then we have 2 different constants and all are less than type constants. So, that means technically earlier structure is that x 1 and x 2. So, we first start with the simple problem that x 1 greater than equal to 0, x 2 greater than equal to 0, or corresponding to this problem. So, x 3 greater than equal to 0, x 4 greater than equal to 0. So, this is the first hand conditions, and the second hand condition is that so it must have integer type, and now this is second condition. Then the third requirement is it is the integer type, and again it will be either 0 or 1. So, that means it is actually one additional constraints we have to put to solve the problems, and that too as per the particular business requirement. So, this is what the restriction which you have to put here. So, now corresponding to this we can actually go to the particular structure and then look for the solution, and here the typical structure will be like this. So, let us start with the tree diagram, and here so we have actually 4 variables. Okay, and then so we start with the first x 1, then connect with the x 2, then connect with the x 3, then connect with the x 4, like stepwise regression. So, it is actually it is a kind of chain, and then we can look for the kind of solution. So, if you start with the x 1s, then there are 2 options only. So, either 0 or 1. So, there is no other alternatives. So, as a result, then if you connect x 2, now x 2 can be either 0 1, either 0 or 1. So, that means technically corresponding to x 1 0. So, x 2 can have option 0 1, and corresponding to x 1 1. So, the x 2 option again have a 0 1. So, that means technically when we have only x 1. So, we have 2 different option only. So, now when we have a 2 variables x 1 and x 2. So, that means technically we have a 4 options. So, either 0 0 or 0 1s or 1 0 or 1 1. So, these are the 4 options. Again, if you add x 3, so that means corresponding to x 1 and x 2, for every x 2 where equal to 0. So, it will be 0 1 again, then again 0 0 0 1, again 0 1 0 1. So, this is how the case, again 1 0, for that x 3 will be either 0 1, then 1 1. So, then for x 3 0 1. So, that means corresponding to x 1 and x 2. So, now we have 2 different option here, 2 different option here, 2 different option here, 2 different option here. So, that means so we have actually 8 options now. So, now again if you add x 4, so then again corresponding to x 1, x 2 and x 3, that to 0. So, we have 2 different options for x 4, again corresponding to x 1, x 2 0 and x 3 1. So, we have a 0 1 option. So, that means technically, so that is how it is a kind of similarly like branching, but it is more interesting like with 0 1 clustering. So, that means we have a plenty of flexibility or plenty of options through which you can address the business problem, and then come with a kind of decision through which you can give some kind of decision, and that to be more effective. So, corresponding to this particular structure, so we can actually summarize, and here so these are all 16 different cases corresponding to the particular business problem. So, that to the 0 1 integer programming. So, we have a 4 variables. So, the way which we have already highlighted here, the kind of chain that can be summarized here. So, that means we have altogether 16 different cases. If you go through here only, so these are all the chains, and then we will find here these are all 16 different cases corresponding to x 1, x 2 and x 3 and different options we have here. So, now if you actually prepare tables and summarize these results. So, this could be like this, and here. So, the first case all are 0. So, that is the case here, 0 0 0 0. Okay. So, this 0 x 1, 0 x 2, 0 x 3, 0 x 4. So, that means typically, so this case, this case, this case and this case. So, this is one particular cluster against 0 or 0 1 and then again 0. So, this is another clusters, like we will have a different kind of clusters again 0 0 0 and 1. So, this is another cluster. So, like that we will have a different kind of cluster depending upon the particular variables involvement. So, now the summary set represents like this. So, we have actually 0 0 0 and that too the value will be 0 because all variables are 0. So, again, so this is a feasible and then constants this is also feasible and this is both are feasible and value of the objective function will be 0. So, now second options 0 0 0 1 and then x 4 equal to 1. So, that means corresponding to the objective function. So, the then the constant. So, it will be appearing 8 and then this is actually value 0 and this is both are feasible and then finally, it will be coming 50. So, likewise we have a different options and every options we have a value of the objective functions and then finally, we will fix a particular solution which can give you with the best optimal value with the condition that the values of the decision variable are integer type, positive and then 0 1 only. So, that means it is actually kind of very restricted kind of game or very specific games and where you cannot apply just each and every problems or business kind of fields. So, so it is a case specific, problem specifics where we have strict three conditions, that to non negativity, integer type and then the values of the decision variable will be only binary in nature, that to 0 1. So, that is how it is called as otherwise called as 0 1 integer programming. So, so that means technically if you sum up, then we have discussed couple of problems here and some problems connecting to primal structure, dual structures, then we have discussed with the graphical structure to solve the particular problem, then we have discussed simplex mechanism to solve the problem depending upon the length of the problems. Then again we have discussed dual and dual simplex methods and again within the particular structure we have discussed integer kind of programming where corresponding to a particular problem, whether it is a bivariate structure or multivariate structure, where the optimality requirement is not to address the business problem more efficiently, but in the same times the values of the decision variable should be integer type. And the third option is the optimal solutions, then the values of the decision variable integer type and then that too they are all in 0 1 interval only. So, that means, so we have discussed a case here with respect to 4 variables and that to x 1, x 2, x 3, x 4. So, as a result we have 16 different cases. So, typically the number of cases in such a situation is nothing but 2 to the power n, and so accordingly if you put another variable say x 5, then the number of cases will be 35. So, 32 sorry. So, likewise if you put another x, then it will be again 2 to the power 6. So, likewise you will find different cases and different flexibility, and as a result we look for different values of the objective functions and then finally you fix the particular situation where the value of the objective function will be high and the particular problem is optimal, will address the business problem effectively, and where the values of the decision variable will be integer and that to either in 0 1 structure. So, that means the corresponding to these problems x 1, x 2, x 3, x 4. So, the minimum entry will be x 1 0, x 2 0, x 3 0, x 4 0 and the maximum entry will be x 1 equal to 1, x 2 equal to 1, x 3 equal to 1 and x 4 equal to 1. And corresponding to these ones. So, sometimes you may not get actually not feasible solution, sometimes you get feasible solution. And this is equally true in the case of simple integer programming, where we are putting branch and bound mechanism. So, while doing so many branches, so you will find in a particular case, so the particular solution is not feasible one. For instance, we have a discussion, we have a structure here like this, this is the case here. Okay, yes, this is the case here. So, while doing the kind of branching, and we have a different options, and in all cases this is one branching, this is one branching corresponding to original problem, this is another branching, this is another branching, this is another branching, this is also another branching, but every case there is a optimal solution, optimal solution, optimal solution, optimal solution, optimal solution, and in some cases mixed integer, some cases it is a pure integer, but here there is a case it is a sub problems and it is through branching, but it does not give any feasible solution. So, likewise this is also case in the case of 0-1 integer programming, and so we have a number of cases. So, that likewise this is a branching. So, if you apply 0-1 game, so number of cases corresponding to the number of variables, and then you will find all such conditions, and then look for the optimal solution, or that is with respect to value of the value of the objective function, and that strictly depends upon the objective function structures. Then just put the values of the variables and look for the value of the objective function, and then fix whether you will reach the optimality, and then address the business problem effectively. So, this is how the kind of requirement, and so we have solved some of the problems in this context, where the optimal solution requirement is the integer type, and that too it is a problem specific, business specific, and case specific, and it the strict warning is that it cannot be apply each and every case if there is no such requirement. So, with this we will stop here, and thank you very much.